Welcome everyone. We will now move to a very important Python concept. This concept is very important. As such, I would like all of you to be 100% focused. And with this concept, we'll complete today's session. I'm not going to take more today, with this being our first day. But this concept, I want everyone to be fully attentive. Mutable and immutable objects. First point, everything in Python is an object. What I mean by that statement is the moment you say A is equal to 10, what will happen? This is, say, your memory. This is your memory, and I create A equal to 10. 10 is a value. A is a variable name. This variable is pointing to 10. Now I write B is equal to 10. I created another variable B. In Python, the moment you say B equal to 10, it will try to create an object having value 10. But before creating an object having value 10, it will see whether there is an object 10 already existing in memory. And if it does, a new object will not get created and B will point to 10 only, the previous object. When I say A is equal to C, A equal to C is very logical. Sorry, C is equal to A. When I say C is equal to A, it is very logical. Assign the value which is associated with A to C. So in that case, C also will point to this. The C is equal to A, the third part of the syntax, which is given here, is very logical. But B is equal to 10. This B equal to 10 pointing to the same object 10, which was created by the statement A equal to 10, is not common or standard across all programming languages. So here, this is the first important thing that you have to understand. And everything in Python is an object. And if you're trying to create a same object the second time, if already it exists in memory, the second variable will point to the first object. And how do I determine? When I say ID, ID is a function which will give you the memory identifier. The memory of our laptop or the memory of our desktop, they have got pointer position. And those pointer positions are IDs where the information is stored. When I run this ID function for A, B, and C, I will get some output. This output is from my previous run. I'll just quickly execute it. But the memory pointer identifier will be same. Let us run this syntax. Control Enter. If you can note, this memory ID of A, this memory position of B, and the memory of C, all of them is same. Kindly execute and try it out. This is the first thing that you have to register in your memory, in your brain. Very important point about Python programming. Okay. Now let us create another variable. D is equal to 20 divided by 2 and check what is the memory ID of D. This is not same as this. Reason being, when you say 20 divided by 2, 20 divided by 2 is some value, and that value will be a floating point value. What I mean by floating point is it is a decimal type. If I type of D, it will say float, and if I say type of A, it will say int. So they will not point to the same memory position. Okay. Now we are going to understand second important aspect of mutable and immutable object. A mutable object is something which can be changed after it is created. A mutable object can be changed after it is created. I'm now getting into the concept of list. We'll definitely see the concept of list more in detail later on. At this point, just understand list is sequence of values stored together in one object. So far when we were saying a equal to 20, there was only one value assigned to a. But when I have sequence of values 20, 30, 40, something like this, and I have to store it in one object, I am making use of an object type list, and this list is a data structure. List is a data structure. So L1 is my first list, L2 is my second list, L3 equal to L1. I will print all of the values of L1, L2, L3, and I am also going to print the IDs. Now here, when you will note that 1, 2, 3, 1, 2, 3, the values are same, but however, the memory IDs of list L1 and L2 will not be same. Reason is when you combine many values of a given data type and put it in a structure, Python will not be able to find out whether all the values are same or not. So in that case, Python creates separate objects. Okay. So single values, it created a say it made use of the same object. However, if you make use of an assignment statement, L3 equal to L1, L3 and L1 will point to the same object. So this time around, when I create L1, L2, L3 in memory, something of this format will happen. There is a 1, 2, 3, and L1 pointing to it. Then I have L2. The values are same, but in this scenario, I'll have a different object being created, though the values are same. Up to a certain point, Python is intelligent. But when I say L3 is equal to L1, this pointer will point to the same object. So let's just execute this part of the code. And here you can note that the memory identifiers of this and this are different. Try running this much piece of code. And then we have to understand mutable concept. Lists are mutable objects. List is a data structure of type mutable, which means the values of the list can be changed. Now in this part of the syntax, I'm saying L1 0. What is 0? Index position. At the first element position, that is represented by index 0, I am changing the value 4. So what I am doing is L1 0 is equal to 4. I am changing this to 4. The moment I change the first index value of list L1 to 4, L3 is actually also pointing to the same object where L1 was. So what has happened is L3 has also changed. Typically, you would not have expected this to happen. In other programming languages, it does not happen. In other programming languages, the moment you would have said L1 is equal to L3 is equal to L1, if you would have executed this syntax, L3 is equal to L1, this content 1, 2, 3 would have actually got copied, and that copy would have been associated with L3. However, the default implementation in Python is if you write L3 equal to L1, L3 will point to the same object which was being referred by L1 also. In case you want to have a copy, there is something called as a copy function. We'll see that later. For now, at a very high level, you have to understand there are certain objects in Python which are mutable, and there are certain objects which are immutable. And if there are two variables referring to same object, like in this case L1 and L3 were both referring to a same object, you make changes to that object through L1, it will also get reflected in L3. You make changes in that through L3, it will also get reflected in L1. So here, when you run this, control enter, 4, 2, 3, 4, 2, 3, I see the print of L1 and print of L3 same because their memory identifier positions, locations are same. If I run the syntax something like this, L3 2 equal to 6, control enter. I now changed the second element of L3, 4 to 6. L1 also got changed because the memory location for both of them is same. I hope you have understood this part of mutable objects and how objects are referred in memory. Let me erase all of these inks. Let us now move to a object which is very similar to list, but we call them as tuple. Tuples are immutable objects. I am creating here an object tuple and the values I am putting is 1, 2, 3, 4. Okay. If I say type one, let me write this one and have one more syntax here, enter, type T1. We will discuss tuples also later more in detail. Tuples are very similar to list. The only difference between tuple and a list is tuples are immutable. Basically, once I created a tuple T1 having values 1, 2, 3, 4, I cannot change any of the positional values. So when I say T1 0, I want to make the first value, this one, as 4. It will give me error. Tuple object does not support item assignment. The pillow code will give error as tuples are immutable, which means once you have associated an object to a tuple kind of a variable, you cannot change the ingredients of that object. In case you want to make any changes, you have to create a new object entirely. So this is a fundamental difference between a mutable and an immutable object. Mutable objects can be changed. Immutable objects, once they are created, you cannot change them. You have to create a new object entirely. And when you are working with mutable objects, you have to remember, if two variables, two or more variables are referring to a particular mutable object, if you make any change in that end object through any of the variables, it will get reflected for all the variables which are pointing to that object. So quickly try the tuple syntax, and with this we will conclude today's session. In our next session, we'll definitely go into more details of lists, tuples, and other data structures. Today, what we have understood is the basic data types. What we have also understood is each value in Python is actually stored as an object. How do we know that each and everything is stored as an object? We came to know by this example, a equal to 10 and b equal to 10. The ID of a and b was same. And then we got into mutable, immutable object, and as part of mutable, immutable object, we covered list and tuples. List and tuples are data structures. I have not completely explained these objects. I've just explained the concept of mutable and immutable objects using the two data structures, list and tuple. So quickly execute this part of the code, execute this part of the code and this part of the code, and check that you get an error message which says tuples are immutable. Thank you all.